value, value. So one dimension system is line, two dimension system is example is surface. So three dimension system is value. Three dimension system is value. Right. So these are the line surface values of the what is that is integrals. 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 So how many integrals we have? We have three. We have three integrals is there. So that is a line integral, line integral, line integral. So second one is that is a surface integral. So third one is a volume integral, volume integrals, volume integrals. We have three integrals is there. So three integrals it is dependent on the dimension systems. That is one dimension, two dimension, and three dimension. Okay. So first of all, so what is the line integral system? You see that. See that one. Okay. So line integral system is in this system we have considered the one curve. We have considered the one curve is a curve. Okay. So in this curve, hence is A.
Which unit is this, sir?
What? This is first unit. This is a continuation. First unit continuation.
Okay.
Okay.
Okay, sir.
Yes, you go to mute. So these are integrals. In our textbook, you see that one. In our textbook, page number is that is 17th, 17, right? So in the line integral is we have to consider the one curve. This curve is AB. This curve is AB, right? So in this curve is a formation of in this formation of number of dots. Number of dot is a dot. So we have to consider one curve. This is curve. Curve. Okay. So number of dots is a number of dots allied with the form of one curve. One curve. That curve hence is AB. AB. So next one, in this curve, we have to assume the any one point on the curve. We have to assume the any one point. This curve is nothing but a number of dot formation. So we have to consider the one dot. And the number of dots we have to consider the one dot. That is one dot we have to consider. We have to consider that the dot name is R, capital R. Dot name is R. Okay. So AB curve is a vector. AB curve is a vector. So vector means you know that the vector is that is magnitude and direction of the system. We have magnitude and direction of the system. So AB curve is the AB curve also is a vector curve. So in this vector curve is it is a formation of number of dots. These are dots also vector dots. Okay, vector dots. So in this dots we have to assume the one dot is assumed dot also vector dot. So vector dot page number 89 Japan 79 and 18. Correct. So these are dot Dot also it is a vector dot. So vector dot means we have to magnitude and the direction. This is a dot. We have to magnitude and the direction. Okay. So these are so magnitude and direction. So first of all, assumed curve AB is a AB curve of length is L. AB curve of length is L. L is a magnitude of AB curve. So this is a direction of curve is a direction. So in the same way, so in the point of length is DL. Total length is L. Then point of PL is point of length is DL. Okay, DL is the magnitude of point. Magnitude of our assumed point value. Okay, so in the L is the curve. Curve magnitude is L. So assumed point of magnitude is DL. Magnitude is DL. It is clear. Okay. So then the curve is a vector. So that's why we have to write the direction of our point is like this. This is the direction. These are direction. Okay. So these are direction. So the direction of our point. So direction angle is theta. Direction angle is theta. Yes, it is clear. It is clear. If once again repeated, AB is the curve. Is a curve is a vector curve. So vector curve means we have to magnitude by direction. So curve it is a formation of number of dots. Curve is a formation of number of dots. So number of dots, in this number of dots, we have to assume the one dot. So assumed dot also is a vector dot. So vector dot magnitude is DL and this direction is A. Direction is A. Direction is A. Okay, or A is there. So for example, this is the direction is R. We have to assume R. Direction is R. Okay, so magnitude is the point magnitude is DL. Then direction is R. Is a formation of curve to is a direction of point. Angle is theta. Angle is theta. So this point is a vector point. So that's why we have to write the RDL. RDL is a direction of point and DL is the magnitude of another point. So R is nothing but a vector, that is RDL. It is clear. So next one. So not only one point in this curve, we have to number of points. So number of points, we have to consider, when we have to consider number of points, automatically is a form of one curve. Okay, so one curve is a total curve value. We can write it to. So in this writing purpose, we have to write the integration of. So integration of means what is that? Integration means we have to assume the all points of values. So each one point of value is RDL. So next one, all points of values we can write it. So that's why we have to add the integration. So integration of A to B. So integration of A to B. These are boundary conditions. These are A to B. Integration of A to B or DL. Is a line integral equation. Okay. Yes, it is clear.
సార్ టెక్స్ట్ బుక్ లోని టాంజెంట్ గీసారు కదా సార్ డిఎల్ కి
రాసుకోవచ్చు RDL, then you can write the cos theta. Dot means నేను ఎస్టర్డే క్లాస్ లో చెప్పాను cos theta. ఓకేనా? సో RDL cos theta అవుతుంది.
ఓకే సార్.
ఓకే,
అంటే ఒకవేళ టాంజెంట్ గీయకపోతే కనుక
RDL. సో cos theta రాయకపోతే RDL అని రాస్తాం. సో డాట్ ప్రొడక్ట్ we have to neglect it means A to B RDL cos theta.
So which means theta tends to 0, then it will be r dot dl.
Yes.
Okay, sir.
Clear?
Yes.
Already before class we had discussed, I think.
సార్ లాస్ట్ క్లాస్ లో గ్రేడియంట్ ఫార్ములా ఒకటే చెప్పాం సార్, డిస్కస్ చేసాము.
Theta minus
డైవర్జెన్స్ ఫార్ములా ఒకటే డిస్కస్ చేసాం సార్ అంతే. ఇంకా ముందు స్కేలర్ ప్రోడక్ట్, వెక్టర్ ప్రోడక్ట్ డిస్కస్ చేసాము. దట్స్ ఇట్ సార్, ఇంకా అంతకన్నా ఏం లేదు.
Now it is clear?
సార్ క్లియర్.
You want to notes?
షూర్ సార్. నోట్స్ రాసాము సార్, అంటే లాస్ట్ క్లాస్ రాసాము.
Okay. Just in this class the line integral notes. You want to notes or not?
సార్, షూర్ సార్.
Okay.
You can provide. We are much obliged.
Okay, right. Okay. The integration
Sir,
of a vector.
Sir, I had one doubt. Sir, can a vector be a curve? Any real-time example for that, sir?
What?
వెక్టర్ ఎప్పుడైనా సరే కర్వ్ టైప్ లో ఉంటుందా? అంటే మామూలుగా మనకు తెలిసినంత వరకు ఎప్పుడు స్ట్రైట్ లైన్ లో రిప్రజెంట్ చేస్తాం కదా, వన్ డైరెక్షన్ ఓన్లీ.
Okay. So if you have magnitude and direction, any one system, that is nothing but a vector.
అది కాదు సార్, ఇప్పుడు ఫర్ సపోజ్
For
10
example,
న్యూటన్స్
see that one.
ఫ్రీ బాడీ డయాగ్రామ్ లో చూపించగలరా సార్?
Your guide, your note is clear. This is also vector.
ఓకే సార్, ఓకే.
Okay.
బట్ in tangential direction only it will act.
Yes, you know that one. Vector means we have to magnitude and direction. So it is not dependent on our angles and angles between 2, 1, 2, 2, 1, 2, 3 like this. It is not dependent. So just magnitude with direction, that is nothing but a vector, any one system. Okay. So
Yes, sir.
is the angles that is dependent on our direction. Okay.
Sure sir, clear.
Alright. Okay. So right, the integration of a vector along a curve is called line integral. Line integral. Let AB is the curve. AB is the curve. AB is the curve. Points. AB is the curve points. AB is the curve point. Then curve length is L. And curve length is L. Curve length is L. Let in this curve, we have to assume one point. Assumed one point. Point of length is DL. Point of length is DL. And direction or smaller. Direction or so we diagram it. Is completed. So R dot DL is a point value. R dot DL is a point value. Point value. Total curve, complete curve AB can be obtained by integrating. Hence, we can write two equations. These two equations you can write it. It's completed. It's completed.
Completed, sir.
So then we have to go to surface integral. I think that board explanation is clear compared to slide explanation. Yes.
Clear, sir. Very better, sir.
Correct. So next one is surface integral. Surface integral. The surface integral. So surface means how many dimensions? We have to two dimensions. Okay. Yes.
Sure, sir.
We have
2D. Two coordinates.
dimension system.
2x.
Okay. So two dimension system. Example is surface. Okay. So this is the surface. So surface is yes. Surface is yes. So total surface value is yes. So this surface is a vector surface. So vector means magnitude and direction. We have to magnitude and direction of surface. So is a surface is a formation of number of small surface values. These are DS1 and DS2 and DS3 and DS4 is a number of surface DSS is a formation of yes. Yes, it is clear. So in the same way, the before one in the line integral system, the number of DLs or number of dots formation is curve. Okay, the same way, number of DSS is a formation of yes. It is clear.
Clear,
Okay,
sir.
correct. So is a one DS value we have to consider is a, for example, these are DS. So this S is a vector, you know that one. S is a vector. So vector means ఈ మెసేజ్ ఏం చేయకండి క్లాస్ ఎంత వరకు ఉంటుంది ఎందుకు వెళ్ళాలంటే రిమూవ్ కాదు ప్రాబ్లం మెసేజ్ పెట్టడం దీనికి 1 అవర్ క్లాస్ మీకు ఇదే ఉన్నట్టు క్లాస్ ఉంటుంది తక్కువ ఈ మెసేజ్ పెట్టు ఎక్కువ రైట్ సో దిస్ ఇస్ ద స్మాల్ పర్టిక్యులర్ వాల్యూ సో ఆల్ స్మాల్ పర్టిక్యులర్ వాల్యూస్ we have to consider as a form of s. So these are ds is a vector. So ds is a vector. These are vector values are smaller. Vector value is smaller. Okay. So ds is the magnitude of another particular value, and is a direction of any particular value is r. Okay. So that is r dot ds is the one value of value. One value or a small value Okay, these are RDS. So number of RDSs is a formation of S. Is the formation of S. S is the surface. S is the surface. So R dot ds or that is equal to RDS cos theta. RDS cos theta. Okay. So RDS, how can we form the theta angle in this ds and R system? ఎట్లా ఫామ్ అవుతుంది? Okay, this is the surface. This is the surface. This is a surface of direction is like this. This is a surface of direction. Okay, so surface and surface direction. Okay, in this between is a form of one angle. This is a theta angle. This is a theta angle. Okay, so these are RDS, R dot ds or RDS cos theta. Yes, these are one particular value. So not only one particular value in the surface, number of particular values is there. So in the number of particular values we have to consider. So in this consider purpose, that is integration. So which one? How many dimensions? Two integrations is two dimensions is there. So in the system we have to use the two integrations or double integration of R ds r dot ds or double integration of R ds cos theta. R ds cos theta. This is the surface integral equation. Surface integral equation. Okay. So this is a small area. This is a ds. This is a small area value is R dot ds. So all small areas we have to consider, then we have to write the double integration of R dot ds. Yes, it is clear.
Clear.
Is it clear? Right. Okay, so we can write it falsely in the surface integral process.
Sir, in surface integral, vector is no longer a point. Its beginning point could be a area, just like a tank moving towards one direction.
Any one direction.
Okay, sir. Okay.
Okay, any one direction, not only particular direction, any one direction. But we have to assume that direction is there.
Sir. Area. So particular area is moving in one direction.
Yes, any one direction.
So angle could be considered from the normal of the surface.
Yes, normal of the surface means is a normal this surface.
Yes,
Is
sir.
a normal of the surface, and we consider the, for example, n, no problem.
And okay, sir. Clear.
Okay, n, no problem. N is the normal of the surface of value. Okay, n. So n dot n ds dot r, you can write it, or ts dot r, you can write it, no problem. As it is clear. So on our textbook n ds dot r is there. Okay.
Yes, sir. Yes.
Right. Clear? Right, you can write it. So you can write it n value as no problem, don't worry about it. But in your textbook, some mistakes is there. A dot ds, an dot ds, that is a dot nds. A dot n dot ds is wrong. Okay, a dot nds. N is belongs to ds value. Yes, it is clear.
Yes, sir. Yes.
Okay. Right. You can write if a surface area S, if a surface area of S in this area small amount of value is ds, small amount of area value is ds. If A is a vector, if A is a vector, if A is a vector of the element ds, the element ds in a direction making an angle theta, in a direction making an angle theta with the unit positive value. Then small area value r dot ds, that is equal to r ds cos theta. R ds cos theta. Then the integral over the surface value is double integration of r dot ds, that is equal to double integration of r ds cos theta. Yes, cos theta. Is completed. Is completed or not?
Completed, sir.
Completed, sir.
What about Chandrika? You want to 2 times repeated? Why? Come on.
Sir, in textbook, they provided that flux of A is equal to double integral of A cos theta ds.
Don't worry about it. Okay, it is enough. Next one, value integral. Okay. Yes, Sanjay, please go to mute. Hello? Mute Kellen, please. Yes, please go to mute. Right. So value integral system. So next one is value integral is there. This the value integral is so value integral is a 3-dimension system example. 3-dimension system example. So the 3-dimension system is you have to consider the value. So this is value. Please. Hello. Hello.
Sir, someone is disturbing, sir. Your screen is not visible to us. Blackboard is not visible to us. Your audio also not clear.
Now it is clear.
No, sir.
Before one. Hello. Now it is clear.
No, sir. We
Yes,
are
sir.
able to see.
Hello.
No, sir.
Okay.
We are able. Clear, sir. Clear.
Okay. Board. What about board?
Board is visible, sir.
value integral value integral. So in this value integral system, we have to assume the one cube. This is the value. So this value or dimensions is we have to three dimensions. These are x, this is y, and this is the dimension system is there. So in the three dimension system of cube, value is v, value is v, value is v. So in the cube is a formation of number of small values, like this. This is the one value, so another value, the number of small values. So the formations like this is the number of small values which is considered as the one of these are total value. So small value is dv. Small value is dv. So v is a vector. V is a vector. So v is a vector means we have to magnitude and direction. So in the same way is the v of the small value also vector values. So dv is a small value magnitude and direction of dv is r. Direction of dv is r. So in the small value of value is that is r dot dv. R dot dv. R that is equal to r dv cos theta. R dv cos theta. So is a small value is r dot dv, that is r dv cos theta. So in the v value we have to number of small values is there. So all values we have to consider. So in this considered process we have to write the triple integration of. So triple integration means this is a value integral of. Okay, we have to write the integration of v. So means what is that? Is a value integration of r. So just like you can write it. These also it's enough. Okay, so triple integration of r dot dv, that is equal to triple integration of r dv cos theta. R dv cos theta. This is the value integral value. As it is clear? It is clear?
Yes, sir.
Yes, sir.
So we can write it fastly.
Textbook representation is different, sir.
What? Okay,
Textbook
it's enough. It's enough.
Okay, sir. Thank you.
So it is not a continuation process in the textbook. So surface is different, separate and surface and line integral is different. So value is different. Okay, it is not a continuation process in the textbook. Part one value integral, but in our process is continuation.
In textbook, they represented with unit vectors and its derivatives. I mean integrals. X integral, y integral, z integral.
Okay, no problem. These are x, y, z. Already show that in our diagram.
Sir.
Okay, right. Yes, it is clear. So in the place of dv, you can write the dx, dy, dy, dz like this. Okay, so right. Right, let us consider
Sir, in textbook they represent a dot d. In textbook there
మనం
is present
ఏమనుకున్నామా A dot B is a before one line లో ఏమనుకున్నాం what is that line and surface R A dot R is there R dot ds and R dot dl is there but in this one A dot db is there. Okay. So continuation process we have to assume R dot db R dot d R dot ds R dot dl like this A dot ds A dot db A dot dl anyone ఏదైనా సీక్వెన్స్ లో ఉండాలి. Yes, it is clear.
Okay.
Sir,
Okay.
on surface integral, can we write integral of x, integral of y into I cap ax plus j cap ay into dx dy? Is it acceptable,
Okay.
sir?
Right. The results are acceptable. R means what is that? IAX plus JAY plus KAZ. R. Yes, it is
Uh-huh,
clear.
I am asking
So
for
dV
surface
means
integral, sir.
yes. dV means what is that? dx dy
Volume
dz.
change. Sir.
Yes, it is clear. These are also same. This is a lengthy process. This is a easy process. This is a
Okay,
continuation
sir.
process.
We got
Yes.
that, sir. We got that.
Okay. Yes, it is clear.
Clear, sir.
Right. It's a easy process. Right. We can write it fastly. Let us consider a closed surface. Let us consider a closed surface in space. Enclose a vacuum V. Enclose a vacuum V. If R is a vector function, small r, if R is a vector function, inside it, and dV is a small element of volume. dV is a small element of volume. Then small element of volume is R dot dl, that is equal to R dV cos theta. Then total volume of volume is triple integration of R dot dV, that is equal to triple integration of R d cos theta. R dV cos theta. R dV cos theta. So diagram, draw the diagram.
Sir, we can follow model questions in the textbook, sir, for exams.
After that, after completion of syllabus, I will give the important questions.
Okay, sir.
Sir, these integrals are useful just for if we know a unit part to predict the whole part. So that is the only purpose of integral, sir.
Only unit part. Unit part means then next one we have to theorems is there. Is a theorems is a long question, compulsory question, long question in our examination kind of. One long question compulsory.
అది కాదు సార్, ఇప్పుడు మనకి యూనిట్ వాల్యూమ్ ఇవి తెలిస్తే మిగతా మొత్తాన్ని ఎస్టిమేట్ చేయడానికి సార్ ఇప్పుడు మనకి
No.
ఈ మొత్తం ఇవన్నీ ఉండేది.
No. This is only belongs to one unit.
సార్ ఓకే
Okay.
ఓకే సార్.
Is completed. So in the line integral, surface integral and volume integral, if you understood, then theorems is easy process. Okay. So in the we have to three theorems is there. That is Stokes theorem is an examination kind of most important questions. So compulsory one theorem is compared in our examination. Okay. So first one theorem is Stokes theorem. Theorem is Stokes theorem. Stokes theorem. Second one is Gauss theorem. So third one is Green's theorem. we have three theorems is there. So in this three theorems, one theorem compulsory is come to another examination. Okay. So first of all, what is the Stokes theorem? What is the Gauss theorem? What is the Prim's theorem? You see that. After that, then we have to prove it. Okay. So Stokes theorem. Stokes theorem is a line to surface. Line to surface. Gauss theorem is this is surface to value. Surface to value system. Yes. So Prim's after that I will discuss it. So in the line to surface, it is possible.
In 2 dimensions, if we have 2 lines, 2 line integrals, then it could be a surface.
Okay, but I am asking to first of all Stokes theorem. Okay, so line to surface is there. So line to surface, so it is possible. Line integral you have to change to surface integral. It is possible or not? So 1 dimension to 2 dimension. 1 dimension, 2 dimension, we have chart. Yes.
I'm not sure, sir.
Okay. Don't worry about it, but just I am asking. Okay. So we see that one. So this is the thread. Okay. This is the curve or is a line. Okay, line is a line integral, for example. Yes, it is clear. Okay.
Yes, sir. Okay. By
This is the
meeting,
line.
we can form, sir.
So yes. So after that, then we have to rotate it like this. Is a modify the surface like this. Yes.
Yes, sir.
Okay, it is possible. So line to surface, it is possible. So means that is a Stokes theorem. Yes, line to surface changes దాన్ని ఏమంటున్నాం మనము Stokes theorem అంటున్నాము. Clear? Okay. So next one, Gauss theorem. Surface to vacuum. It is possible surface to vacuum. ఈ థియరం చెప్పేస్తే క్లోజ్ అయిపోతుంది ఫస్ట్ యూనిట్. Don't worry about it.
Bit more
Okay.
complex, sir.
Right. So Gauss theorem is surface to vacuum. It is possible. Hello. It is possible or not?
Maybe, sir.
Maybe, may not.
Not sure. Possible, I think so, sir.
Okay, it is possible. So because yes. Okay, this is the surface.
By
Yes.
folding it, sir.
Isn't it? It is the surface.
No,
So
sir.
in the surface, we have to consider the one cube or one house like this. We have to construct it. Okay, like this we have to construct it. So Emantam, for example, we have to purchase the one plot. Okay, so plot purchase means what is that? That is the surface. That is the surface. On the surface, we have to construct the home. Okay, home construct, illu construct చేసిన తర్వాత దాని ఏమంటాం? ఇల్లు అంటాం, ప్లాట్ అన్నాం కదా.
Yes, sir.
అంటే ఇల్లు house means what is that? This is a 3 dimension.
Volume, 3 dimensional.
Yes,
So
sir.
means
Volume,
what is that?
3-dimensional volume.
Yes, yes. We have to convert it to surface to value. It is possible. Yes. Okay. We have to convert it to surface to value. This is an example, good example. Yes, now it is clear.
Clear, sir. We can make a square to cylinder as well
Yes.
by folding it.
Yes. These are Gauss. These are Gauss. Surface to value means changes is Gauss. Okay. So Stokes theorem and Gauss theorem, I think that it is clear. How can we modify it and how can we use it in the system? Okay, it is clear. So then we have to go to in the Stokes theorem statement. After that, Stokes theorem proof. Just very easy. First of all, you have to write the statement, one statement. So that statement we have to prove in the proof system. First of all, you have to write the line integral equations. Second one is a surface integral equations. So So finally, line integral equal to surface integral like this. You can write it. So close Stokes theorem. It is very easy. So this is a easy process. అర్థమవుతుందా? Okay. So first of all, in the Gauss theorem also, we have to write the surface values. So this is the first one equation. So next one is we have to write the values. This is the second one equations. So after that, first one equation equal to second one equation. So is a Gauss theorem system. Gauss theorem system. Okay, it is clear. Is a
Yes,
process of Stokes theorem and Gauss theorem. So how can we prove in our Stokes theorem and Gauss theorem? Roughly you know that. So these are we have to write it down. What is what? Okay. Right. Next one class, I think that is 150. Okay. So next tomorrow class, I will be discussed all three theorems. Okay.
Okay, sir.
So
Thank you.
tomorrow,
Okay, sir. Okay,
and
sir.
our first one unit completed. Tomorrow,
Okay, sir.
break padutuni first unit close out the day.
Okay, sir.
All right. So every point we have to discuss it in the first unit. You see that one? Just to do. Right?
Yes, sir.
Okay. Thank you to one and all.
Thank you.
Thank you, sir.
Sir, last class notes ఇంకా తెలియదు సార్.
Hello.
సార్ లాస్ట్ క్లాస్ నోట్స్ సార్.
లాస్ట్ క్లాస్ నోట్ చెప్పినాం కదా నాన్న. క్లాస్ ఏ క్లాస్ ఆ క్లాస్ నోట్ చెప్తున్నాం కదా. నేను రాసుకోను కదా లాస్ట్ క్లాస్ నోట్స్.
సార్ this is the first class sir, so I'm asking sir.
Okay, but you ask to and our friends means
Sure.
Anyone please share in group.
Sure. Yes.
I will try, but I'm not sure. I note it roughly.
WhatsApp.
No problem.
Yes,
Maurya, you can share
just
whatever. No problem.
roughly.
We can understand, no problem.
Okay. Rough work also it is enough.
Rough work only makes more sense sir, than fake notes.
Okay. We modified it. Okay. Thank you.
Okay, sir.
Bye.
Thank
Okay,
you,
sir.
sir.
Thank you, sir. Thank you, sir.
Bye.
Guys, hello.
Yes?
ఎవరైనా ఉన్నారా? హర్ష.
Huh.
అదే మేము ఏంటంటే ఎవరికైనా ఇంట్రెస్ట్ ఉంటే, ఇఫ్ ఎనీవన్ ఈజ్ ఇంట్రెస్టెడ్, అంటే క్లాస్ లో మ్యాథ్స్ సార్ చెప్పింది అర్థం కావట్లేదు కదా, సో ప్రాబ్లమ్స్ మనం ఓన్ గా సాల్వ్ చేసుకోలేకపోతున్నాం. ఒకళ్ళ వల్ల అయితే అవ్వదు. సో టుగెదర్ ఎవరైనా సరే ఇంట్రెస్ట్ ఉంటే కనుక సో షేర్ చేద్దాం అనుకుంటున్నా. గ్రూప్ ఫామ్ చేసాము. ఎవరికైనా ఇంట్రెస్ట్ ఉంటే జాయిన్ అవ్వచ్చు.
Okay.
Please join me. Please speak in English.
అంటే ఇంట్రెస్ట్ ఉంటేనే, అంటే దాంట్లో మేము ఏంటంటే ఎగ్జామ్ సంబంధించిన ఇన్ఫర్మేషన్ కానీ ఇవేం మేము ప్రొవైడ్ చేయలేము. జస్ట్ ఏంటంటే ఇన్ఫర్మేషన్ అంటే కంటెంట్ కి సంబంధించి షేర్ చేసుకోవడం తప్ప మరి ఏమీ లేదు.
Okay.
Please join.
లింక్ ఏదైనా ఉంటే ప్లీజ్ సెండ్ చేయండి.
అదే షేర్ చేస్తున్నా.
What's your name? Maurya hai kya?